Okay, we're gonna do a mixing problem. So I got a 100-gallon tank. Okay. Well, I got a 100-gallon tank, got 50 gallons of water in it. Okay, and then I'm gonna pump, a certain concentrated salt solution into the tank at 3 gallons per minute, and then we're gonna pump it out or drain it out at 2 gallons per minute. Okay, so what we're looking for is a function that describes how much salt is in the tank at any given time t. Okay, so if we have a concentrated solution coming in to pure water, it's going to mix and then it's going to leave. Okay, so well, let's just get started. What do we know? We know we got 100 gallons initially. Well, no, we don't. It's a 100-gallon tank. We have 50 gallons initially. Okay, and this will probably take 2 videos to do, so just bear that in mind. Okay, and what do we got? We got solution entering the tank at 3 gallons per minute, and it looks like it's leaving the tank at, I'm going to put a negative sign in front of it. Okay. All right, it's leaving at 2 gallons per minute. So let's see here, and x of t will describe the salt, and it looks like it'll be in pounds. Let's just stick to pounds, gallons, and minutes for our units. So let's find out how much salt pound-wise, mass-wise, is coming in. Okay, so what do we got? So we got salt in. Okay, so that is going to be, it's coming in at 0.4 pounds per gallon. And then we're going to multiply that by 3 gallons per minute. Okay, and that's going to give us 4 tenths, so that's 12 tenths, that's 1.2 pounds. The gallons cancel out per minute. So the salt is going to come in. See, so that the salt is going to come in at 1.2 pounds per minute, and it's going to leave it at a rate with the same units. And that should make sense because x of t, it's a in this case it's a mass over time. So x of t, t being time, so that looks pretty good. And that's usually pretty obvious. So now let's look at the salt out. So on the inflow, I knew that I had 0.4 pounds per gallon as my concentration. The only problem is right here, I don't know what my concentration is going to be. Okay, it's unknown. It's actually x of t, and that's what we're trying to hunt down ultimately. So let's just write that down. And the concentration is always, in this case, it's going to be, pounds per gallon. So let's see here. We got 50 gallons in the tank, but our volume, we got 3 coming in, we got 2 gallons coming out. So our volume's actually going to change over time. So we're going to have to write the volume as a function of t. Okay? And this will be pounds per gallon on our units. Okay, and then we're going to do the same thing. This is basically our unknown stuff, but we do know how fast it leaves the tank, and it leaves at -2 gallons per minute. Okay, and so that's going to give us basically a grand total of -2. I'm just going to write x instead of x of t. Pounds. The gallons cancel out, and that's v of t minutes. Okay. Now the next thing we're going to do is we're going to find v of t. We can't find, x of t, is going to be the last thing we figure out. It's, the solution to the differential equation. But v of t is actually another differential equation within the differential equation that we're going to figure this out. So let's take a look at what's going on here. Okay, so we do have a change in volume, right? We got 3 gallons coming in, we got 2 gallons coming out. So dv, it might be fairly obvious, but more complicated ones, you're going to want to go ahead and write this out. So I got 3, it's the sum of all the rates of change. Okay, so I just summed up everything. If this thing had like 5 hoses in it and 15 holes leaking out, and I just happen to know exactly the rate of change on each one of them, doesn't really matter, because all I'm worried about is the level in the tank. Okay, so we just add them all together. Just make sure, you know, you have your signs properly applied. Okay, so when we're gonna kind of scrap the units for right now. Just when we do the actual analytic part, and we're going to say dV dt is equal to 1. Okay, so if I want v of t, all I have to do is integrate this with respect to t. And it's a very simple integral. It is t plus c. Okay, so what is c? So c, well, at time equals 0, the volume is equal to 50 gallons, right? So that's our initial value problem for the volume. So I'm just going to write 50 gallons at t equals 0. Okay, so, you know, very simple differential equation. So v of t is equal to t plus 50 gallons. Okay, so at any time t, here's how many. Here's the volume of the tank. So what I'm going to do is I'm going to take this and I'm going to plug it in to this right here. And technically, I guess I really should plug it into this, because I already canceled out the gallons when I did my multiplication here. You see that? So, I mean, really, I guess to be proper, I would be plugging it in here. Okay, but since I already did the math, the units canceled out, I don't have to worry about the gallons anymore. So all I have to worry about is this right here. Okay, so let's take a look. So what do we have right here? We have a salt. We have an amount of salt coming in, and we have an amount of salt coming out. So that is what? That's a change in salt content over time, isn't it? So couldn't I just say that, just like we did with the volume, couldn't I just say that dx dt is equal to 1.2 pounds per minute plus negative 2x pounds over t plus 50 minutes? Okay, I could go ahead and say that, couldn't I? Wouldn't be out of the question. And I like to just kind of, I mean, it depends, you know. Usually I scrap the units, but sometimes you want to keep them. But just for simplicity, I'm going to go ahead and just, I'm just going to rewrite it just like this. Okay, so there it is. There's my differential equation, and I think I'm at it. So we still have to solve it, and we will do that, but I just think I ran out of time. So hopefully you caught all this. I think the only really complicated part is this v of t right here. Okay, and I hope I made that clear how we go about and figure this out. Okay, so I'm gonna finish this in the next video. We got it all set up now. We're gonna solve it. Okay.